How do CFD solver algorithms like SIMPLE and PISO work? Imagine trying to solve a puzzle where the pieces constantly change shape. That's what computational fluid dynamics software does when analyzing how fluids move. Today, we're looking at two key algorithms that help make sense of these fluid puzzles: SIMPLE and PISO. They are essential tools in design and analysis for engineers working with computational tools. Let's start with SIMPLE, which stands for Semi-Implicit Method for Pressure-Linked Equations. It's mainly used when the flow doesn't change over time, called steady-state flow. The process begins with guessing the pressure field in the system. Using this guess, the software solves the momentum equations to find an initial velocity. But this velocity might not satisfy the mass conservation rule, which says that fluid must be neither created nor destroyed. To fix this, the solver creates a pressure correction equation. Solving this adjusts both the pressure and velocity fields. This cycle repeats many times, updating the values each time until the flow satisfies the conservation of mass within a set tolerance. SIMPLE needs some relaxation factors to keep the process stable, which can slow it down but makes it reliable for steady flows. Now, PISO, which stands for pressure implicit with splitting of operators, is a step up for transient or time-dependent flows. It builds on SIMPLE but adds extra correction steps within each time step. It starts the same way, solving the momentum equations with an initial pressure guess to get an intermediate velocity. Then, it solves the pressure correction and updates the velocity accordingly. The key difference is that PISO performs multiple correction loops, called neighbor corrections, within each time step. These loops help the solver satisfy both the momentum and mass conservation equations more accurately. Because of these extra steps, PISO can reach convergence faster per time step, which is especially useful for unsteady flows. However, it requires smaller time steps to stay stable, following rules like the Courant-Friedrichs-Levy condition. In practical terms, SIMPLE is often used when the flow is steady and doesn't change over time. PISO, on the other hand, is better suited for simulations where flow varies quickly, like in turbines or pulsating fluids. Although PISO does more work per iteration, it reduces the total number of iterations needed, making it efficient for dynamic problems. Both algorithms can be adapted for different types of flows, whether compressible or incompressible, with some modifications. In the world of mechanical engineering, these algorithms are the backbone of CFD software, used to analyze everything from pumps and turbines to heat exchangers and aerodynamic parts. Understanding how they work helps engineers choose the right method for their specific problem, balancing accuracy and computational cost. So, in simple terms, SIMPLE corrects pressure and velocity step by step for steady flows, while PISO performs multiple corrections within each time step to handle changing flows more efficiently. Both are vital tools in the toolbox for fluid analysis.